Good evening to all. This is problem number 4 from the GATE question. It is given in GATE 2010. It is given for 1 marks. So this system is represented by the equation y of t equal to integral of minus infinity to phi t x of tau d tau for t greater than 0 is. So here we have to check for linearity and causal system. Linear and causal. Okay. So two conditions. So first condition we will solve for causal. Okay, for causal. So what is the condition for causal system? The output should depend on the present and past input. Output should depend on present and past input, but not future inputs. Not future inputs. This is the condition for causal system. So let me take the equation system representation. So what is the system representation? That is output representation y of t equal to minus infinity to phi t x of tau d tau for t greater than 0. So let me apply the limit t equal to 1. So this equation will become y of 1 minus infinity to phi x of tau d tau. So if we apply the limit here, lower limit and upper limit, this is x of phi minus x of minus infinity. Okay. So this output value, it depends on future inputs and past inputs. This minus infinity is past input and this phi is future, because the output t value is 1 only. Okay, at the time value 1, but it depends on the phi time value. So this is future input. So what is the condition for a causal system? The output should depend on present and past input only, but not future input. So this system depends on future input. So this system is non-causal system. Non-causal system. Okay, non-causal system. Now let me check for linearity. So what is the condition for linearity? We have to apply the superposition principle. So before that, let me find y1 of t and y2 of t. So from the output relationship, we can find y1 of t as minus infinity to phi t x1 of tau d tau. y2 of t as minus infinity to phi t x2 of tau d tau. Okay. So what is the principle? Response to the weighted sum of input signal should be equal to weighted sum of output signal. We can find the response to the weighted sum of input signal. So in the place of x of tau, we can replace this whole equation. So the equation will become minus infinity to phi t. In the place of x of tau, we can replace the whole term, that is a x1 of tau plus b x2 of tau into d tau. Okay. So this is taken as first equation. So this is the response of the weighted sum of input signals. So let me find weighted sum of output signals. A into y1 of t plus b into y2 of t, that is equal to, so let me apply this value y1 of t and y2 of t. So a into minus infinity to phi, integral of minus infinity to phi t x1 of tau d tau plus b into minus infinity to phi t x2 of tau d tau. So see the equation, it is a constant term. So we can rearrange this equation, that is a can be taken outside. So here also b can be taken outside. Integral can be applied for the individual term. So this equation can also be written as a into minus infinity to phi t, integral of minus infinity to phi t into x1 of tau d tau plus integral of b into integral of minus infinity to phi t x2 of tau d tau. So this first equation and second equation is same. So the system is linear. System is linear. Okay. So this system is linear and non-causal system. Linear but not causal system. Option B is the correct one. So one note, all the integrators are the linear system only. All integrators, integral equations, integrator or linear system only. Okay. Thank you.